Are we on the next example, or did we get? We're still on the same one?
We didn't find A. We did B equals Y.
Oh, that's right. That's right. Okay. We were decomposing. Decomposing. So this one will pick up where the other one left off, kind of, sort of, not really. I'm probably going to have to run through the equation to begin with. So we're decomposing into partial fractions. 8y plus 7 divided by y squared plus y minus 2. So the first thing we did, so this is going to catch us up to where we were in our notes. So if you guys were not paying attention at the end of yesterday, pay attention now. We turned that into 8y plus 7 divided by y plus 2 times y minus 1. So we're going to decompose this. So we're going to take this and turn it into a over one of our factors plus b over another one of our factors. And yes, you can always just put a plus right there. Thank you, Lucas. You can always just put a plus right there because of the fact that if b ends up being negative, then that'll change it to a minus, right? So we don't care what's there right now. I put a plus because it's easily changeable if it needs to be. So then remind me at the end of the period.
Does it matter which one we put over what?
No. It doesn't matter which one, because the answer will pop out. What goes over y minus 1 will come out. What goes over y plus 2 will come out. He's fine. He can.
No, Mr. Bates, I was like, can you stop moving your head, please? And you went.
He probably didn't even hear you. He probably was just moving his head naturally. Let's assume to the positive. All right. So we're going to multiply both sides by y plus 2, y minus 1. All of our factors, because we want to cancel everything. Those will cancel. And then this will cancel, but this will still have a y minus 1 left over, and this will still have a y plus 2 left over. If there are any questions, make sure you guys stop me. Not just mumble. Where'd Aiden go? Huh? Oh, Miss Jamie. So after we got to this point, we want to cancel a. So we said let y equal 1. So if we let y be 1, that's really funny. We pick a number to cancel out a. Yeah. It's funny because we said let y be 1, and that's funny because anybody can pick up on it. This will be a very esoteric piece of knowledge, but topical to lunch. I said, does anybody pick up on the funny reference? Because it's topical to lunch, but it's still an esoteric reference, which means not often thought about. So I said let y be 1, and one of the characters in Coraline is YB. So, anyhow. All right, so we have 8 times 1. That was rude. And take that out of your ear, Lucas. All right. So we were there. That's what we did. So we found out what B is. B is 5. So now we're going to find out what A is. So we're going to let y equal -2. So now we're going to have 8 times -2.
Okay, wait, can you stop, please? You are going crazy fast.
Well, this is literally where we stopped yesterday. So all of this was written yesterday.
I didn't write it. I didn't have time. I'm so sorry. I'm just... See, look, everyone else is writing too, Mr. Bates.
And it's the people that I got after at the beginning for not being on topic. Yes, Tylee. As a matter of fact, you notice that Tylee is not writing because he was focused yesterday.
Never mind. That's a 3B, right? Or is that a
3B.
Alright, because I put BB and I was like confused for a second, but I'm good now.
And he took context clues. This guy's trying to change his game.
Oh my god, don't make him feel good about himself.
Wow. Don't,
He doesn't need that.
Tylee, nobody likes you, including yourself. It be like that sometimes. No. Tylee, you're a wonderful human being.
She wants you to sing the
All right. So I want to cancel out b, so I let y equal -2. I get 8 times -2 plus 7 equals a times -2 minus 1 plus b times -2 plus 2. So this is going to be 0, so this is going to cancel. Albert, if you'd like, you could speak a little louder with your funny accent so we can hear what you're saying. Yeah, but I need you to do it in the voice that you're using when you talk to Nathan right now.
Sure. In the end, you'll get -16 plus 7 is equal to a -3a.
Okay,
SpongeBob.
keep going.
I got it.
That would then simplify to -9 equals a -3a. And after you divide both sides by -3, you get a is equal to 3.
All right.
I got that one. Wait, what?
Yes, what's wrong, Jada?
Oh, I'm a little.
Sada, are you falling asleep? Did the sriracha knock you out? We should get the example down, Sada. You haven't even started it.
So I wasn't gonna tell you because I was gonna tell you something, but now you're gonna yell at me.
I'm not yelling.
Can you pause that really quick?
I can't, not from right here.
All right, don't read it out loud.
Compressing our middle infield double plays.
Guys, think about the question. Is this the answer? Get it from my tone. No, this is not the answer. I wanted you to decompose into partial fractions. So the final answer is actually going to be our starting fraction equals 3 over y plus 2 plus 5 over y minus 1. So I'm going to write that in just a second.
She's writing a whole
Okay,
story.
got you.
Thank you.
Okay,
I know what I'm doing. I'm just gonna teach myself.
well, that's not really teaching yourself. Yeah. All right. I'll move it in a second. All right. So the final answer is that is the final answer. Decompose 8y plus 7 over, actually, I mean, technically I should have put the actual intro problem. Yeah. Y squared plus y minus 2 equals 3 over y plus 2 plus 5 over y minus 1. So it is now decomposed into its component pieces. It's not.
But there's more.
It's now decomposed into its pieces. Yeah. So what's going on here, Amaya? I know. I knew it was wrong, but I still said it. That's why I stumbled.
Yeah, you did.
I stumbled because I was like, why am I going to say that? Why am I going to say that? And then I said it.
All right.
Anyhow, Amaya, what's going on here is when we want to know what made this. So it's important to be able to take a look at something and say, we've got this final answer. Well, what pieces possibly came in to create this? And we might be able to decompose it into partial fractions. And that's what's going on. That's why. You know, when we're studying pure math in high school, you never know what this is going to exactly go into depending on what field. When we start hitting the hardest topics in Algebra 1, honestly, and above, we're talking about math that the majority of people in real life, quote unquote, are not going to use except for the top 2% of the world. And when I say top 2%, I'm talking about people who are physicists and whatnot. I'm not saying, necessarily better than anyone or anything like that, right? Medical field, engineering fields, physics fields, they're going to be using this mathematics. However, of course, high school mathematics, the purpose here here for high school mathematics is just so that way we shore up our logic skills and our problem solving and processing. It's exercise for the brain. If the more we are able to do things like this, the more logically we're able to think, the more our brain takes over when we need it to in life instead of our emotions.
Mr. Gansky said to be smarter, all we have to do is read. He said that's the only thing. He said that's the only thing we have to do is read a million words a year.
Or 3,000 words a day.
Which is like 10 pages.
I think I would argue that not only would I would be partially okay with that. I would say that you also have to be able to think about what you read. Because I'm capable of taking a look at something and just going, if a rational inequality is not expressed at one fraction. Okay. And not think about it at all. I read the words.
As long as you put words in your brain.
Pavlovian is conditioned responses. That's ringing of a bell causes dogs to salivate.
What's the one where they hypnotize them to know what score?
Oh, I don't know. That's not Pavlov though.
What if you cannot, I have a question. What if you cannot factor a denominator?
Those are both factorable.
No, but that says it's a partial fraction.
All right.
You can't do this method here. I'm talking about for this.
This is solve. There is no. We don't. Yeah, you don't have to. You don't have to factor it. Like this one was nothing to factor there. That one did factor, but that only helped us out with it. So, all right, guys. Are we on the last example? Page 18, 19. No, we still have two examples. Two examples, guys. Rational inequalities. Lucas? Okay. Rational inequalities are next. These they take up space, so be careful, Destiny. These take up space. But they're not too hard. But they do take up space. All right. So solving a rational inequality. Let me just steal it. Solving a rational inequality, we have x minus 2 times x minus 1 all over x minus 3 times x minus 4 is less than 0. I've already got these factored. So we want the solution to this. When is this less than 0? When is this less than 0? It's going to be very easy. The first thing we find is our test points. Our test points based off the factored form, which, like I said, on this one I was nice and I gave you the pre-factored form. Our test points based off the factored form, we set each one equal to 0. So kind of off to the side here, I'm going to put test points. Yes, and a lot of you guys can skip to the easiness on this. X minus 2 equals 0. X minus 1 equals 0. X minus 3 equals 0. X minus 4 equals 0. Huh? I don't know. I was just reading it. Yeah. We good? I just took each one of my parentheses, set them equal to 0? All right, so this is going to give me x equals 2, x equals 1, x equals 3, and x equals 4. And I just realized now that I made all of them a negative sign, and that made all of my results positive. You guys get it, that it would be whatever the opposite sign is, right? Okay, so these are my test points. If I put in 2, what would I get? I'd get 0. If I substituted 2 into this, I'd get 0, because that would make that one 0, and 0 divided by anything is 0. If I plugged in 1, I'd get 0. If I plugged in 3, I'd get undefined because I'd be dividing by 0. If I plugged in 4, I'd get undefined because I'd be dividing by 0. So these are the points that my test points, quote unquote, are the ones I can't plug in. But I know something's going on around these points. So I pick things less than, greater than, and in between. Less than, greater than, and in between. So what is my smallest point? Okay. So I'm going to make it like an X. I don't know. I'm going to make it like an X and Y chart. Yeah, let's do this. Okay. All right. I'll come take a look at your paper. You're fantastic.
Really?
Yes, you're
Thank
absolutely
you so
good.
much, Mr. Bates. That means a lot.
Well, I meant your paper, not
No,
like.
no, you
So, I did. So let's go in order. What's my lowest number? 1. So I'm going to go less than 1, right? Less than 1. So if I plug in something, now this is all mental math. Be okay with that. Destiny, you're going to be all right. Destiny will be all right. I'm telling you. All right? We're going to pick a number less than 1. Pick it and pick decimals. Just do it. Okay? 0.5. 0.5s are great. Okay? 0.5. So if you guys pick 0.5, so no calculator. No calculator. Okay? So we're going to pick 0.5. So here's what you guys do with these, because the question is less than 0. What numbers are less than 0? Negative numbers are less than 0. Are we all good with that? Negative numbers are less than 0. So if I plug in 0.5, 0.5 minus 2, is that positive or negative? Negative. 0.5 minus 1, is that positive or negative? Negative. 0.5 minus 3, is that positive or negative? Negative. 0.5 minus 4, is that positive or negative? Negative. So a negative times a negative divided by a negative times a negative is? Positive. Because I only care if I pick a number less than 1, will that be less than 0? Yes or no? No. I'm gonna pause for a second and make sure that's understandable.
Okay, say that again. I wrote no.
So this ended up, so if I picked a number less than 1, I got a negative times a negative divided by a negative times a negative. That whole thing's positive. My question is, when is this function less than 0? So when is this function negative? Well, it's not here because it's positive. So if this inequality was flipped, this would have been a yes. Well, no, we got to test everywhere. So now I've got to test between my next 2 test points. What's the next test point after 1? 2. So I've got to pick something between 1 and 2. 1.5. Sorry, I missed my X on that less than 1 part. So now I'm picking something between 1 and 2, so you guys say 1.5. 1.5 minus 2, is that positive or negative? Negative. 1.5 minus 1, positive or negative? Positive. 1.5 minus 3, negative. 1.5 minus 4, negative. If I got an odd amount of negatives, the whole thing is negative. Yes. Yes. No, you can't think for a second.
So if it's a negative times a positive,
Is negative.
it's negative. Oh, we want it to be negative.
We do, because our question is when's it less than 0? So my test points were 1, 2, 3, and 4. So I need to check less than my smallest, and then I check between the numbers. Yep, I'm going to have to check between 2 and 3, between 3 and 4, and greater than 4. 2. Top right, because 1.5 minus 1 is a positive number. There's going to be a little bit of a squeeze. I'm going to have to scroll. Wee. All right. So between 2 and 3, right? I'm going to pick 2.5, right? 2.5 minus 2. 2.5 minus 1. 2.5 minus 3. 2.5 minus 4. So that whole thing is, it's positive, Indigo. Yeah.
Because negative times negative.
Yeah. I don't like that, no. All right. Between 3 and 4. And greater than 4. Tyler, you all right with this?
Yeah.
Cool. Tyrell? I don't have any other ties.
So long as it's greater than 4, you can choose any number above.
Any number above 4. Yes. 1 million minus 1. Positive.
X to less than 4.
Greater than 4.
Greater than 4. Why is it?
Because I said, so here are my test points, right? I pick less than this number, then between, then between, then between, then greater than this number. So if you think of a number line, I had 1, 2, 3, 4. I've got to test this area first. That was a no. I test this area next. That was a yes. I test this area next. That's a no. This area next. That was a yes. This area last. That's a greater than 4. Did you guys catch Indigo's question? Okay. Because the only one, she asked why I switched to x is greater than 4 at the end, so I drew this number line. My test points were 1, 2, 3, 4. So I've got to test less than 1 to get this side of the number line, between 1 and 2, between 2 and 3, between 3 and 4. And then on this side, this would be x is greater than 4, so that's why I tested greater than. So my answer, guys, when it comes down to what do you write as the final answer, right, it's where it's a yes. Those are my answers. Yes. Yes. One more example, but yeah, that's it for this problem.
So you're telling me I could have wrote bigger.
But if I had said that, you know, who knows?
Just what I wrote huge.
Yeah.
I wrote this on the entire page.
Yeah. See? Got your back.
Thank you, Mr. Bates. I really appreciate it.
What's the last question? I was reading. I was reading.
Yeah, Tylee.
Okie dokie. Last example. Last example. We've got rational inequality expressed as one fraction, is not expressed as one fraction, sorry. We have 2 over 3a plus 5 over 6a. Now, there are a lot of different examples I give in your homework, so make sure you guys give those a good, honest effort. is greater than 3/4. Step 1 is find my test points where the denominators equal 0, or the numerators if I need to as well, right? Just like the last one. So anything with a variable. Anything with a variable. This is the next example. Oh, these are the test points again? So this one gives me a is 0. This one also gives me a is 0. It's redundant. Fine. I got it. I'm going to check to the left and right of 0. Here's an issue, though. I also made this one not greater than 0. Very simple solution. Move the 3/4 over, so I'm just testing for positives and negatives. Because if I'm just testing for positives and negatives, it makes my life easier. If I'm actually testing for when is this greater than 3/4, then I actually have to put real numbers in and solve it out that way. But if I'm just checking greater than 0 or less than 0, I can just be looking for positive or negative solutions, and I don't have to do all the complicated stuff. So first of all, let's go ahead and get a common denominator amongst all these. 12. A. 12A. So our common denominator is going to be 12A. We can move the 3/4. You know, a lot of these steps are interchangeable. I believe 2 and 3 are pretty interchangeable here. I'm going to move the 3/4 over first. In retrospect, I like that better. So I've got 2 over 3A plus 5 over 6A minus 3/4 is greater than 0. Multiply both sides. Not multiply both sides. Let's get a common denominator, sorry. Common denominator. And that's important. I'm not trying to get rid of the denominators right now. I want a common denominator first, just in case. Just in case. So, as Indigo said, our common denominator will be 12A, so this is going to be multiplied by 4 over 4. This one will be multiplied by 2 over 2. And this one will be multiplied by 3A over 3A. So I'm getting a common denominator. If you guys want to write that off to the side as what we're doing in this step. How long does it take you to go through a bag of those, Indigo? A week? How long would it take you, Victoria? For those of you who could not hear in our audience, Victoria would go through one in a few minutes. One bag of Starburst mini candies, which has 8 servings per container at 110 calories each. So you could actually go through an entire bag and eat 880 calories and still be under calories for the day. So, hey. If all you're counting is calories, that's good. If you're watching your blood sugar and chance of developing diabetes, this is bad. What was your question, Watkins? 1 cup. 1 ounce. 1 ounce per serving.
How much does each one weigh?
Doesn't say. Oh, it says about 19 pieces. Okay, is everybody okay with the fact that I just moved 3/4 over and then I got a common denominator? Yes. So let's go ahead and combine them all. So if it did, it's not going to create a new test point. It's not going to create a new test point, you know, but if it did, we might want to write down over here whatever the new one is. This is not going to give me anything special. It's just A equals 0 again. But just in case this leads you to a new test point, be aware. In case it leads you to a new test point. So if you see something that's different from the rest, create a new test point. Okay? So what's 8 plus 10? So we have 18 minus 9a over 12a is greater than 0. So now we're going to build that chart, but we only have one test point. Our test point is 0. So we're just going to check to the left of 0 and to the right of 0. X is less than 0. X is greater than 0. We're going to check to the left and to the right of 0. So what would be an easy number less than 0? Now, since we're only got one test point, let's go with integers. Let's not even pick decimals. Let's make our life easy. -1 would be super easy number less than 0. -1. What's 18 minus 9 times -1? It's 27, but more importantly, positive.
Wait. We're plugging 1 in for.
We're gonna check a number less than 0, which would be negative. That'll turn into a negative times a negative. So we're gonna have a positive number on top and a negative number on bottom, which makes a. I don't know. That's sloppy. Yes. Oh, I put X, didn't I? Good call, Indigo. But you didn't, Jada. Quit trying to take her thunder. Indigo gets confused because I put X right here, but technically it's an A in this equation. Yes? Right. Correct. It's just a placeholder. A is less than 0, so we're going to get a positive on top, a negative on bottom, and that's going to is a positive by a negative is a negative. So this one's a no because we're looking for greater than 0. Now I'm wondering why. Oh, we have a second test point. I missed it. Yeah, it's multiplying. I didn't even realize why. Here's what I'm not thinking about, right? This is another test point. Two is a test point. So Jada asked a great question. I just glanced at it and I realized my mistake when I glanced at it. Doesn't make it. Still a question, and I'm saying it's a great one. So the way I realized it was because of the fact that we have a positive. Huh? No, it's 2.
Yeah, you add 9 to both sides.
Yeah. So Aaron, I didn't do all the steps. What do you want to do? Like subtract 18 or something? Yeah. It doesn't matter because right here we have a negative divided by a negative. You're good. All right. That's where I got that. So the way I looked at it, Jada, was I saw it's 18 minus something, right? 18, and I'm subtracting, and I'm multiplying and subtracting. So if I multiplied 9 times 3, what would I get? 27. 18 minus 27, that's what kind of number? Negative. So I realized that it's not 0 wasn't the only test point. I had to bring in that other one, and I was like, where did I miss it? Oh, I didn't count the numerator. That's my fault. So once I got a common denominator, I have to bring in that numerator as another place to check a test point. So I'm going to check greater than 2. So first of all, between 0 and 2, I think we got it down here. We're going to pick 1, right? I think that'll be our easy test point. Let me bring that down. And I'll end up with a positive divided by a positive, which is positive. So that'll be a solution set. And then A is greater than 2. I'm going to switch back because now that negative number on top is going to outweigh my positive number on top. And I'll end up with a negative divided by a positive. And that's going to be negative, and my answer is no. So my only solution for this one is A values between 0 and 2. What time is this period over on a MIM day? 21. So we'll have 12 minutes for you guys to get a jump start on your turn in class. Just because Mr. Richards is right there, I'm going to